Hi there, this is Penelope, this is FS3128. Now we're on to the last topic of the course, topic 8, and we're going to look at trigonometry part 2 for the first class, and this is where we've got a non-right-angled triangle. I'll do a brief revision of right-angled triangles, but we're mainly now looking at non-right-angled triangles. So, some things to know. In a scalene triangle, all sides are different lengths. That makes the angles different as well. In an isosceles triangle, two sides are equal. And in an equilateral triangle, all three sides are equal. And just something that you might remember is that the sum of the angles in a triangle, any triangle, equal 180 degrees. Okay, there's some triangles that are different. The one on the left is an isosceles triangle. The one on the right is a right angle triangle. So this is isosceles. This is a right angle triangle. Now you could conceivably get a right angle triangle that is isosceles, but this is not what we're talking about here. So let's have a look just to remind you of right angle. Now it is really important that you only use these methods when you've got a right angle triangle. So in the left-hand diagram, in number 1, we'll call it number 1. In number 1, we can find YZ, that's YZ, or little x, by using Pythagoras' theorem. So YZ is equal to the square root of 41 squared minus 9 squared, which is 40, which actually shows us then it's a nice right angle triangle because Pythagoras' theorem works. Now, what we also remember is that sine x is equal to 40, the opposite, over the hypotenuse, and therefore that x is equal to the inverse sine of that, which is, if we're talking in angles, 77.32 degrees. That means we can find the other angle as 180 minus 90 minus that, because 180 is for the right angle, then minus what we've just found, and that will give us angle Z, only little one, 12 degrees, 12.68 degrees. For 2, triangle 2, sine of C is going to be 35 over 37, so C is going to be sine inverse of 35 over 37, which, if we're using degrees, is 71.08 degrees. Now we can find angle B as being 180 minus 90 minus 71.08, which would be another tiny angle, 18.92 degrees. We can find the length of AC as being the square root of 37 squared minus 35 squared, which is 12. Again, that's another obviously right angle triangle, so it all works. We could have found that another way. We could have said that sine B was equal to AC over 37, so AC was equal to 37 sine B, and found it that way. But we got the same answer. Now, non-right-angled triangles, all right? Non-right-angled triangles. There's a picture of one here. Then we can use the sine rule, maybe. We're going to use the sine rule when we've got one side and two angles. or if we've got two sides and an angle, but the angle that we've got is not included between the two sides. The diagram here shows us, or we can work out that angle ACB, that's that angle there, is equal to 180 minus 28.83 minus 131.15 degrees, which gives us 20.02 degrees. So using the sine rule, CB over sine, now the one that's opposite is 28.83 equals AB, and you're given that AB is 20 over sine of this angle here at C. So CB is equal to 20 times sine 28.83 divided by sine 20.02. Now if we work that out at the straight away now, our answer is going to be a little bit inaccurate, so we can leave our answer in there to go now using right-angled triangle stuff to say that CD is equal to CB times the sine of 48.83 degrees. Now CB is what we already found. And multiply that by sine 48.83, and we get the approximate answer of 21.21 meters. Then another rule that we've got is the cosine rule. Again, it's not for right-angled triangles. The cosine rule is used when two sides and an included angle are given. Or when all three sides are given. You can use this kind of stuff to find the area of any triangle. We know that the area is equal to half the base times the perpendicular height. And now we know that we could say that that's half the same thing, AB sine C, or a half AC sine B, or a half BC sine A. Or another way of writing it is that it's the square root of S times S minus A, and then an assignment question on this, I think, where S is now we will do this one in class, and we will do this one in class.